Before installing or servicing a sauna heater, it is important to always consult with a qualified electrician. Improper wiring can pose a fire or electrical hazard. Let's discuss wiring diagrams for sauna heaters. Firstly, let's consider a single-phase heater. A common voltage is 240 volts. The amperage typically ranges from 15 to 60 amps. For wiring, use 12/2 or 10/3 THHN stranded wire. A wiring diagram for a 240 volt main service would look like this. There is a fixed junction box and a circuit breaker that leads to the sauna heater. It is crucial to ensure proper grounding. Secondly, let's examine a three-phase heater. Voltages can be 208 volts or 240 volts at 60 Hz. Amperage ranges from 15 to 60 amps. Recommended wiring includes 12/3 or 10/4 THHN stranded wire. A wiring diagram for a 208 volt or 240 volt main service features a fixed junction box, circuit breaker 1, and circuit breaker 2. The wiring diagram assumes the sauna is located no more than 50 feet from the electrical panel. If the distance is greater, consult with an electrician to determine the appropriate wire gauge and circuit breaker amperage. All connections must be made in a fixed junction box. The sauna heater must be properly grounded. You should always consult the heater manufacturer's instructions for specific wiring requirement. For additional tips, use a surge protector to protect the heater from voltage spikes. It is also advisable to install a ground fault circuit interrupter outlet near the sauna for added safety. Lastly, have a licensed electrician inspect the wiring annually to ensure it is safe and code compliant. Let's delve deeper into the specifics of single-phase wiring. A single-phase 240 volt circuit typically involves two hot wires and a ground wire. The 12/2 or 10/3 THHN stranded wire recommendation refers to the American wire gauge size and the number of conductors within the cable. The THHN insulation type indicates that the wire is suitable for dry and damp locations and can withstand temperatures up to 194 degrees Fahrenheit. The first number, 12 or 10, represents the wire gauge, with a smaller number indicating a thicker wire capable of handling more current. The second number, 2 or 3, indicates the number of current-carrying conductors plus a ground wire. A 12/2 wire contains 2 insulated conductors and a bare ground wire, while a 10/3 wire contains 3 insulated conductors and a bare ground wire. It is important to select the correct wire gauge based on the amperage of the sauna heater to prevent overheating and potential fire hazards. Consult the National Electrical Code, specifically Table 310.15b16 for ampacity ratings of conductors. A fixed junction box is a crucial component of the wiring system. It provides a secure enclosure for making electrical connections and protects the connections from damage and accidental contact. All wire splices and connections must be made inside the junction box, following proper wiring techniques. The junction box should be securely mounted and accessible for future inspection and maintenance. The circuit breaker is a safety device that protects the electrical circuit from overloads and short circuits. It is important to select a circuit breaker with the appropriate amperage rating for the sauna heater. The circuit breaker should be installed in the electrical panel and connected to the power supply wires. When an overload or short circuit occurs, the circuit breaker will trip, interrupting the flow of electricity and preventing damage to the wiring and equipment. Proper grounding is essential for electrical safety. Grounding provides a low resistance path for fault current to flow back to the source, allowing the circuit breaker to trip and clear the fault. The sauna heater must be properly grounded to prevent electrical shock hazards. This is typically achieved by connecting the heater's grounding terminal to the building's grounding system using a grounding conductor. The grounding conductor should be sized appropriately for the circuit amperage. Now, let's move on to three-phase wiring. Three-phase power is commonly used in commercial and industrial applications and can provide more efficient power delivery than single-phase power. A three-phase 208 volt or 240 volt system typically involves 3 hot wires, a neutral wire, and a ground wire. The 12/3 or 10/40 HHN stranded wire recommendation is similar to the single-phase wiring, but with an additional current-carrying conductor. The 12/3 wire contains 3 insulated conductors and a bare ground wire, while a 10/4 wire contains 4 insulated conductors and a bare ground wire. Again, selecting the correct wire gauge based on the amperage of the sauna heater is crucial. The wiring diagram for a 3-phase system involves connecting each of the 3 hot wires to a separate circuit breaker in the electrical panel. This circuit breaker should be properly sized for the amperage of the sauna heater. The neutral wire, if present, should be connected to the neutral busbar in the electrical panel. The ground wire should be connected to the building's grounding system. As with single-phase wiring, all connections must be made in a fixed junction box, and the sauna heater must be properly grounded. Now, let's discuss some additional considerations for sauna heater wiring. The distance between the electrical panel and the sauna heater is an important factor in determining the appropriate wire gauge. Longer distances require thicker wires to minimize voltage drop and ensure adequate power delivery to the heater. If the distance exceeds 50 feet, consult with an electrician to determine the correct wire gauge. Voltage drop is the reduction in voltage that occurs along a wire due to its resistance. Excessive voltage drop can cause the sauna heater to operate inefficiently and may even damage the equipment. Using a thicker wire can reduce voltage drop and improve performance. A surge protector is a device that protects electrical equipment from voltage spikes. Voltage spikes can be caused by lightning strikes, power surges, or other electrical disturbances. These spikes can damage sensitive electronic components in the sauna heater. A surge protector can absorb or divert these spikes, protecting the heater from damage. A ground fault circuit interrupter, commonly referred to as a GFCI, is a safety device that protects against electrical shock hazards. A GFCI outlet detects imbalances in the electrical current and quickly shuts off the power, preventing electrical shock. Installing a GFCI outlet near the sauna provides an extra layer of safety. Regular inspections by a licensed electrician are essential for ensuring the safety and reliability of the sauna heater wiring. An electrician can inspect the wiring for signs of damage, wear, or corrosion. They can also test the circuit breaker and GFCI outlet to ensure they are functioning properly. Regular inspections can help identify and correct potential problems before they become serious hazards. Let's summarize the key points of sauna heater wiring. Firstly, always consult with a qualified electrician before installing or servicing a sauna heater. Secondly, determine whether the heater requires single-phase or 3-phase power. Thirdly, select the appropriate wire gauge based on the amperage of the heater and the distance from the electrical panel. Fourthly, use THHN stranded wire for its heat resistance and durability. Fifthly, make all connections in a fixed junction box. Sixthly, properly ground the sauna heater. Seventhly, consider using a surge protector to protect against voltage spikes. Eighthly, install a GFCI outlet near the sauna for added safety. Ninthly, have the wiring inspected annually by a licensed electrician. Finally, always follow the manufacturer's instructions for specific wiring requirements. In addition to these points, it is important to understand the relevant electrical codes and regulations in your area. The National Electrical Code, or NEC, provides comprehensive guidelines for safe electrical installations. Local building codes may also have specific requirements for sauna heater wiring. It is your responsibility to ensure that the installation complies with all applicable codes and regulations. Failure to do so can result in fines, penalties, and potential safety hazards. If you are unsure about any aspect of the wiring process, it is always best to consult with a qualified electrician. They can provide expert guidance and ensure that the installation is done safely and correctly. Remember, electrical work can be dangerous, and it is not worth taking risks. Protect yourself and your property by hiring a qualified professional. Let's recap the wire gauge selection process. The wire gauge is determined by the amperage of the sauna heater and the length of the wire run. The higher the amperage or the longer the wire run, the thicker the wire needs to be. Use the NEC table 310.15b16 to determine the ampacity of different wire gauges. Choose a wire gauge that has an ampacity rating greater than or equal to the amperage of the sauna heater. For example, if the sauna heater draws 30 amps and the wire run is 50 feet, you would need to use at least a 10 American wire gauge copper wire. If the wire run is longer than 50 feet, you may need to use a thicker wire to compensate for voltage drop. There are online voltage drop calculators that can help you determine the appropriate wire gauge for longer wire runs. When making electrical connections in the junction box, it is important to use proper wiring techniques. Strip the insulation from the ends of the wires, being careful not to damage the conductors. Use wire connectors, such as wire nuts or crimp connectors, to join the wires together. Make sure the connections are tight and secure. Wrap the connections with electrical tape for added insulation and protection. Do not over-tighten the wire connectors, as this can damage the wires. When grounding the sauna heater, connect the grounding conductor to the heater's grounding terminal and to the building's grounding system. The grounding conductor should be sized appropriately for the circuit amperage. The grounding conductor should be green or bare copper. Do not use the neutral wire as a grounding conductor. The grounding system should be properly bonded to the building's metal water pipes and other metal structures. This helps to create a low resistance path for fault current to flow back to the source. When installing a GFCI outlet near the sauna, choose a GFCI outlet that is rated for outdoor use. Outdoor GFCI outlets are designed to withstand moisture and other environmental conditions. Follow the manufacturer's instructions for installing the GFCI outlet. Test the GFCI outlet regularly to ensure it is functioning properly. The test button is located on the front of the outlet. Press the test button to trip the GFCI outlet. The reset button should pop out. Press the reset button to restore power to the outlet. If the GFCI outlet does not trip when the test button is pressed, it is not functioning properly and should be replaced. When having the wiring inspected annually by a licensed electrician, ask them to check the following items: the condition of the wiring insulation, the tightness of the electrical connections, the operation of the circuit breaker, the operation of the GFCI outlet, the grounding system, and the overall safety of the electrical installation. The electrician should provide you with a written report of their findings and recommendations. Follow their recommendations to ensure the safety and reliability of the sauna heater wiring. In conclusion, sauna heater wiring requires careful planning and execution to ensure safety and compliance with electrical codes. By following the guidelines outlined in this video and consulting with a qualified electrician, you can ensure that your sauna heater is wired properly and safely. Remember that electrical work can be dangerous, and it is always best to leave it to the professionals. This information is for educational purposes only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician before performing any electrical work. Remember, safety is paramount when dealing with electricity. Never work on electrical circuits while they are energized. Always turn off the power at the circuit breaker before working on any wiring. Use appropriate personal protective equipment, such as safety glasses and insulated gloves. Be aware of your surroundings and avoid contact with any metal objects while working on electrical circuits. If you are unsure about any aspect of the wiring process, stop and consult with a qualified electrician. It is better to be safe than sorry. With proper planning, careful execution, and a focus on safety, you can ensure that your sauna heater is wired properly and safely, providing you with years of enjoyment.